Hello children, today I am here to teach you chapter 30 in your textbook. That's your last unit, tessellation. So we started tessellation in grade 7. So we are checking more about tessellation in this lesson. So we are identifying what regular tessellations and semi-regular tessellations are. Select suitable polygons to create regular and semi-regular tessellations and create regular and semi-regular tessellations. So last time we just discussed in grade 7, we discussed what are tessellations and we took several shapes and find out tessellation work and we created it. So we are now trying to create regular tessellations. What is regular means? All lengths are equal. So what is tessellation? Covering a certain space using one or more shapes in a repeated pattern without gaps and without overlaps. We did pure tessellation. Pure tessellation is when we are using only one shape. It's called pure tessellation. So what is this shape? It's a hexagon. So all these are hexagon only. Here squares. So one shape. So those are pure tessellations. Semi-pure tessellation, you can use two or more shapes. What are the shapes used here? Squares and triangles. In tessellations where rectilinear plane figures are used, the sum of angles around each vertex point is 360 degrees. So here when you take any point, it's 360 degrees. So any point around the vertex point. So we call these a vertex point. So around a vertex point is 360 degrees. So remember that. And when you are tessellating, what are the important two properties? No gaps and no overlaps. Review exercise in your textbook. In your exercise book, draw a tessellation consisting of only equilateral triangular shapes. So you can take an equilateral triangle and we'll try to tessellate this. I'll take another copy. Another copy. So all these are equilateral triangles. When you rotate and keep it here, you get the same shape. I'll put it here. We'll take another copy and we'll try to paste this one here and another copy. Paste it here. So here these are all equilateral triangles. So this is a tessellation works. So you can put colors now. So I'll put different colors now. And blue here. So this is a tessellation with equilateral triangles. For each of the following tessellations, write with reasons whether it is a pure tessellation or a semi-pure tessellation. So first diagram, only triangles are there, equilateral triangles. So equilateral triangles only. So then we can say this is pure tessellation. This one, squares and triangles. So this is semi-pure tessellation. Triangles and squares. Triangles and squares are used so this is semi-pure tessellation. This one shape only. This is like an arrow, but one shape they used. So this is pure tessellation. As only one shape is used. This one, do you get the same shape? No. The yellow ones are different to blue color parts. So this is semi-pure tessellation. As two different shapes are there. Shapes are used. What about this one? Triangle and this part. So two different shapes. Semi-pure tessellation. As two different shapes used. Select and write the numbers of the plane figures which are regular polygons. Regular means all sides are equal as well as all angles are equal. So this is an equilateral triangle. Angles as well as sides. So one is a regular polygon. All angles 90 and all sides are equal. That's a square. 2 is a regular polygon, but 3 is not a regular polygon. All sides are not equal. That's a rectangle. Here this is a rhombus. Even though all sides are equal, angles are not the same. So this angle is different to this angle. So that's not a regular polygon. Here all sides are equal, but the angles are different. Not a regular polygon. And this is a hexagon. All angles and sides are equal. So that's a regular polygon. We'll do an activity. Trace these regular polygon shapes onto colored paper using a tissue paper and cut out 10 shapes of each kind. Create a regular tessellation using only the triangular shapes and paste it in your exercise book. So we'll try to do that. This is an equilateral triangle, a square, and this is a pentagon and hexagon, regular hexagon. So we'll do that. First we'll do the equilateral triangle. So I have equilateral triangle. So I'll try to tessellate. So I'll take 1, 2, 3, 4, and here I'll keep 5, 6, 7, 8, 9, keep this one also here like this. So this is a tessellation with regular polygon, that means equilateral triangle. So I can color this. And I'll put green color like this and another color. So this is a tessellation. We'll take the square now. We'll try to tessellate. You get something like this. So we can color this. So we'll color with different ones. 1, 2, 3. And we'll use another color, orange. I'll put it here. And you can take different colored papers and see what you get. So this is tessellation. Now we'll take hexagon, regular hexagon, and see what's the tessellation work we can create. So we have this shape. So we'll create here also. So this is a tessellation with regular polygon, that's a regular hexagon. Now we'll try to color this. You can color you can put any color that you like. So I'll put, and here this is again the same color here, and we'll put 2 different colors there. Yellow. So this is a tessellation with regular hexagon. Now when we try with a pentagon, regular pentagon, so when you rotate and try to fit this, you are not getting a tessellation. So here, what happens here? You get a gap in between. So tessellation means no gaps and no overlaps. So why we are getting this? Now think about this point. So in this point, the angle around the point should be, vertex point should be 360. Now in a pentagon, what's one angle? So one angle, how you find? What's the angle? So you get how many triangles? 3 triangles there. So 3 times 180. So you get 540 for all angles. Divide by 5, you get 108 degrees each. So this is 108. This is 108. And this is 108. 108 3 times. What's the value? 108 degrees 3 times 324 degrees. So we need 360. So that's why we are not getting tessellation with regular pentagon. So this one, the angle inside is not divisible with 360. So this is not divisible. So according to the above activity, we can create regular tessellations by, what are the 3 shapes we did? We did with squares, equilateral triangle and regular hexagon. With those 3 shapes you can do tessellation, but not with regular pentagon. So here this is the tessellation work with equilateral triangle. Now focus one vertex point. Equilateral triangle, one angle is 60 degrees. So 360 divide by 60 degrees, 6. So that means when you take one vertex point, there are 6 equilateral triangles you can fit. Then you get 360. So that's why it tessellates. When you take the squares, this is the vertex point, each angle is 90 degrees. So 360 divided by 90, you get 4. 4 squares fit it and make 360 degree angle. So that's why it tessellates. In a regular hexagon, what's one angle? 120. So 360 divided by 120, you get 3. That means 3 hexagons will make one vertex point. So that becomes 360. So that's why it tessellates. So these are the shapes, regular shapes that tessellates. Equilateral triangle, square and regular hexagon. So regular tessellation means a tessellation created using only one regular polygonal shape is known as a regular tessellation. So, and also you need to remember, when creating a regular tessellation, a vertex of one geometrical shape should not be on a side of another geometrical shape. So that means this is not regular tessellation. So you can't take one vertex point there. That's not a vertex point. But when it comes to here, this is regular tessellation. Here, this is the vertex point. So remember, what are regular tessellation? You use only one shape and vertex point should be there. Semi-regular tessellation means tessellations created using 2 or more regular polygons and such that the same polygons in the same order, when considered clockwise or anti-clockwise, surround each vertex point are called semi-regular tessellation. So here, this is what they say. So now when you take the point A, vertex point A, we'll take clockwise starting from triangle. You get triangle 1 and a square then, and then a square and a triangle, another triangle. So that's the order when you take clockwise. We'll take another vertex point. You need to get the same pattern. If you take this point, okay, we'll start with the triangle here. If you take this triangle, now we are doing anti-clockwise. Triangle, triangle, triangle. 3 triangles together and 2 squares. So same thing. So if we start from this triangle here, so starting from anti-clockwise, triangle, then square, 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 and then another 2 triangles. So same order you are getting. So that means this is a semi-regular tessellation. You get 2 or more shapes, and also when you take clockwise or anti-clockwise, if you are getting the same order with the shapes, so that's a semi-regular tessellation. So this is semi-regular tessellation. What about this one? Take this point A. When you take point A clockwise, we start from hexagon, hexagon, triangle, hexagon, and the triangle. Now we'll take other way around. So this is clockwise. Anti-clockwise, we'll start from hexagon. Anti-clockwise this way. Hexagon, triangle, another triangle, and hexagon. Now, do you get the same pattern? You are not getting the same pattern. So this is not a semi-regular polygon. Not a semi-regular tessellation. So this is not a semi-regular tessellation. There are 8 types of semi-regular tessellations that can be created on a plane. They are given below. So these diagrams, I took it from the textbook, and when you go through the internet, you can see all these shapes. Now we'll see. We can take any point and check. If you take this one, when you do clockwise, hexagon, triangle, hexagon, triangle. If you take any point and do anti-clockwise, hexagon, triangle, hexagon, triangle. So any point is okay. So that means semi-regular tessellation. We take here any point here, triangle, square, hexagon, square. We'll take this one. So that's, we did triangle, square. So clockwise. Anti-clockwise, starting from triangle, triangle, square, hexagon, square. So you get the same order when you rotate the angle clockwise or anti-clockwise. So that means that's a semi-regular tessellation. So when you take any point like that, you get same thing. Here, clockwise, triangle, square, triangle, triangle, another square. Take a look at another point. We'll take this point. So we can start with this one, triangle, and see whether you get the same. Anti-clockwise, triangle, square, triangle, triangle, square. So you get the same order. So you can check all these vertex points and see these are semi-regular tessellations. Exercise 30.1. What are the regular polygons that can be used to create regular tessellations? We can use equilateral triangle, we can use square, and regular hexagon. How many types of regular tessellations are there? So how many types? 3 types. These 3. Each interior angle of a certain regular polygon is 98 degrees. Explain whether a regular tessellation can be created using this polygon. So this should be divisible by 360. This angle, when you divide, you need to get a whole number. So 360 when you divide by 98. Do you get a whole number? You are not getting whole number, so that means doesn't fit it. So we can check how many 98s. 3. So 3, 98 times 3, 294. So 360 minus 294, you get 66 degrees remaining. So that's not divisible by 98. So that means this is a decimal value. So you get a decimal answer. So you can write not divisible by 98 degrees. That means not tessellating. So you can write not a regular tessellation. Some figures are given below. Select and write the letters corresponding to the figures which are regular tessellations. So regular means only one shape it's using. So you can use equilateral triangle, squares or hexagon. So A is regular. And here this is hexagon. B is regular. And F, you get regular one. And the other shapes you get 2 or more. Now semi-regular tessellation, how you identify? So we'll take this one, C. When you take any point, now here more than 2 shapes, square, triangle and hexagons are there. So when you take one vertex point, you need to identify the order, clockwise or anti-clockwise, whether you are getting the same order. So when you take clockwise, hexagon, square, triangle, square, hexagon, square, triangle, square. Then when you take another point, any point there, now we did clockwise, now do anti-clockwise, hexagon, square, triangle, square. So you get the same thing. So that's regular. That's semi-regular tessellation. This one, we'll take any point. So clockwise, we'll do clockwise, square, this is a heptagon. 1, 2, 3, 4, 5, 6, 7, heptagon. Square, heptagon, heptagon, you get that when it goes here clockwise. Anti-clockwise, we'll take any point and see anti-clockwise what you get. Anti-clockwise this way, square, hexagon, hexagon. So same thing you are getting anti-clockwise way. So that's a semi-regular. This one, take any point, take clockwise, we'll take from triangle, 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 hexagon and triangle. Now that's clockwise. We'll take any point here and anti-clockwise. Triangle, 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 triangle. 4 triangles and then hexagon. Or I'll start with this triangle and see. Triangle, 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 hexagon, triangle. So you get the same thing. That means semi-regular. And this one, take any point. So take clockwise. Hexagon, triangle, hexagon, triangle. We'll take this point and see whether you get the same thing. So now we have to try anti-clockwise. Hexagon, triangle, hexagon, triangle. So you get the same thing. So G is semi-regular. Now take the next one. It's not even regular. It's rectangles. All sides are not equal. So that's not either a regular tessellation or semi-regular tessellation. Identify regular and semi-regular tessellation here. So here 1 equilateral triangles, that's regular. Here also J, only one shape and it's regular tessellation. K, squares, that's a regular one. And here all sides are equal, but these are not squares. Angles are not the same, not regular polygons. So that's not a regular one. That's not even semi-regular. 2 or more shapes, only one shape is there. So not semi-regular as well. So when you take this one, so more than 2, so it can be semi-regular. So we'll see the order. If you take the clockwise, square, square, triangle, triangle, triangle. If you do other way around, square, square, triangle, 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 order is the same. So M is semi-regular. What about this one? These are not regular shapes, so not even semi or regular. This one, this can be semi-regular. Look at this one. This is square, square, triangle, triangle, triangle. When you take other way around, square, square, triangle, triangle, triangle. Order is the same. So O is semi-regular. This point, take a vertex point. This is more than 2 shapes. So clockwise, triangle, triangle, hexagon, hexagon. And this way, anti-clockwise, triangle, triangle, hexagon, hexagon. Same order. So that's semi-regular tessellation. Look at this one. Q. What's this shape? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. Dodecagon squares are there. And hexagon. 3 shapes. See the order? Dodecagon, square, hexagon. Other way around, if you take 1 point, hexagon, hexagon, square, dodecagon. Hexagon, square, dodecagon. And if you take any point here, this way. Now we did hexagon, square, this one anti-clockwise. Now we'll take clockwise, hexagon, square, dodecagon. So that's the same. So you can take Q also as semi-regular tessellation. What about this one? What's the shape? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon, 12-sided polygon. So dodecagon, dodecagon triangle, clockwise. Anti-clockwise, dodecagon, dodecagon triangle. That's also possible. explained with reasons whether each of the following tessellations which have been created using regular polygons is a semi-regular tessellation or not. So we need to identify a point and see the order. So when you take this vertex, hexagon, triangle, hexagon, triangle. That's clockwise. We take this one and anti-clockwise, hexagon, triangle, hexagon, triangle. So the order is the same. So this is semi-regular tessellation. And the order is the same here or here. Anti-clockwise or clockwise, the order of shapes are the same. This one, 2 or more shapes, and we'll see any vertex point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. So you get hexagon. So I'm doing clockwise. Hexagon, square, dodecagon. And anti-clockwise. So we'll take any point and do anti-clockwise. Hexagon, square. So we'll see hexagon is this one, square, dodecagon. Same thing. So this way or this way, same thing. So semi-regular tessellation. So you can say this is used hexagons and triangles. 2 or more shapes, that's semi-regular. So here dodecagon, then square and hexagons are used. So 3 shapes used in this one. Miscellaneous exercise. Prepare several regular, semi-regular tessellations that are suitable for wall hanging. So these are pictures I have taken from your textbook and the internet. You can search for different tessellations. So all these are regular as well as semi-regular. Here this is a regular one, only used equilateral triangles. This one squares, triangles and semi-regular one. Here used hexagon, square and triangles. This one hexagon, triangles. So all are regular and semi-regular tessellations. So we covered all theory related to tessellations. A tessellation created using only one regular polygon shape is known as regular tessellation, and tessellations created using 2 or more regular polygon shapes and such that the same polygons in the same order, when you rotate clockwise or anti-clockwise, you get the same order. Those are semi-regular polygons. So try out different tessellations and enjoy. You can cut and paste different shapes and try nice tessellation and be creative.